There was a problem in sharing. I will share again. Are you able to see the slides? Hello. Okay. So, welcome to week 2 tutorials of NPTEL PMRF tutorial on pericyclic reactions and organic photochemistry by Professor S. Shangaraman from IIT Madras. Myself, Anisha Suresh, PMRF TA for this course from IIT Bombay. So, in this week, in the module, sir have discussed regarding Diels-Alder reaction and 2 plus 2 cycloaddition reaction. So, we will be solving some problems based on these two. So, coming to the first question. The major product formed in the following reaction is. So here they have given an allene and an alkene substituted with two esters. So it is subjected to heat and it will result in the formation of one of these four products. What will be the right answer? So what sort of reaction is taking place here? Anyone please respond? Like what sort of reaction is taking place here? Is it Diels-Alder reaction or is it 2 plus 2 cycloaddition? Hello? So here a 2 plus 2 cycloaddition reaction is taking place. So the alene system will be one two component, two electron component, and the this alkene will be the other two electron component. So let us see, like out of this two or two pi systems, which one will be taking part in the 2 plus 2 cycloaddition reaction, whether it is the substituted part or the other part. So based on the explanation, here we can see this alene system will be showing a 2 plus 2 cycloaddition reaction, not a Diels-Alder reaction. Then the less hindered double bond of alene will participate more in the reaction and will give the major product. Less hindered double bond. So this is the less hindered double bond. It will be taking part in the 2 plus 2 cycloaddition reaction rather than this double bond. Okay. So this double bond will be taking part in the 2 plus 2 cycloaddition reaction with this alkene. So this is a trans system. So the product that we will get is trans. This is a trans system. So the product that we get is trans. We have seen that there will be a superficial kind of overlap between the orbitals. So hence whatever the geometry of the alkene is there, it will be maintained in the product. So, the less hindered double bond of alene will be participating in the 2 plus 2 cycloaddition reaction. So it is a concerted reaction, 2 plus 2 cycloaddition reaction. And since the overlap is superficial kind of overlap, the geometry of the uh, this double bond, this is a trans double bond, so it will be maintained in the product. So here we will get the trans product. So the correct answer will be option 2, that is this one. Okay, any doubts? So the point that you have to remember here is the less substituted uh, double bond will be taking part in the 2 plus 2 cycloaddition reaction. And here since this is a trans alkene, so the product will also be trans or anti. Okay, so this is the final product that we will get from this reaction, 2 plus 2 cycloaddition reaction. 2 plus 2 cycloaddition reaction. Is this question clear? Any doubts? Now coming to question number 2. Predict a product with the correct regio and stereochemistry. So the question number 2, 3, 4 and 5. It will be based on this. We should predict the product with the correct regio and stereochemistry. So here the starting material is given. The starting material is given and it is subjected to thermal condition. So what will be the reaction that it will undergo and what will be the product that we will get? We have to work it out. There are no options given in this question. So what sort of reaction will be taking place here? Is it a 2 plus 2 cycloaddition or a Diels-Alder reaction? Hello? Is anyone there? So here we can see this is the diene component and this is the dienophile. So it will undergo a 4 plus 2 cycloaddition, or we will call it as Diels-Alder reaction. So this is the diene component and this is the dienophile that will take part in Diels-Alder reaction. So we will see how the reaction is proceeding. So this is the diene component, and for Diels-Alder reaction we have seen that it is mandatory to have a schizoid conformation of diene. Diene should be schizoid. So here we can see the diene is in transoid conformation. But it is possible for this double single bond to rotate, and we will be able to get this schizoid conformation of the diene. Understood? The single bond rotation is feasible. Hence it will rotate and we will get the schizoid conformation that is mandatory for the Diels-Alder reaction to take place. Now we are having this schizoid conformation, the Diels-Alder reaction. So we can see this is the 4 electron component and this is the 2 electron component. So it will undergo a Diels-Alder reaction and we will get this 6 membered 6 fused system. So here this will be 1, 2, 3, 4, 5, 6. Here a bond will be forming. 1, 2, 3, 4, 5, 6. So it is a 6 fused system. And we know it will be following endo rule. Because of this carbonyl secondary overlap will be possible. And because of that it will follow endo rule of Diels-Alder reaction, and hence this group will be coming below the plane. Since this will come below the plane, and these these two groups you see, these are in the same fashion, same direction. So both the hydrogens, they will be they will be coming in the same side. So the hydrogen here, it has shown beta, so this methyl group will be coming alpha, because this hydrogen, it should be beta. As we can see here, both the groups that are facing outwards of this diene system, it will be on the same side. So both the hydrogens, that will be on the same side. That is why here it is shown this hydrogen is beta. So this hydrogen should be also beta. Hence the methyl group will be coming alpha. And we have seen this this bond and this bond, they are trans with respect to each other, and hence this CHO is coming below the plane. This group should come above the plane, and the hydrogen which is on the same side of the CHO, it should come below the plane. Hence we are having a trans decalin system. Is the stereochemistry clear? The first aspect is, for the Diels-Alder reaction to occur, the diene should have the cissoid conformation. So this single bond will rotate and we will get the cissoid conformation. Then it will follow endo rule of Diels-Alder reaction, and it will undergo the 4 plus 2 cycloaddition in a concerted fashion, and the stereochemistry will dependent upon the endo rule that we have followed. This CHO will be below the plane, hence this hydrogen which is on the same side of the CHO will also be below the plane, and this hydrogen and this hydrogen, it will be above the plane, hence this methyl will be below the plane. So this is the answer for the question. This is the regiochemistry and the stereochemistry for the given reaction. Is this clear? Hello? If you're giving response, I will be able to understand that you have understood whatever I have discussed here. Hope you have understood. Now we will move to question number 3. Here also we have to predict the correct regiochemistry and stereochemistry of the product. So here two starting materials are given. It is subjected to thermal condition. We will get a product A. That product A, upon further heating, we will get some product B. So we have to predict the correct regiochemistry and the stereochemistry of the products. So what sort of reaction will be taking place here? So here we are having a diene. A schizoid diene we are having, and this is our dienophile. So it will undergo a 4 plus 2 cycloaddition reaction, also known as Diels-Alder reaction. Okay. Now let us see what will be the stereochemical aspects of this reaction. So here a diene is there, a dienophile is there. It will undergo a 4 plus 2 cycloaddition as shown here, and we will get this bridged cyclohexadiene system. Bridged cyclohexadiene system we will get. And if we further heat it at 200 degrees Celsius, this system, it will isomerize. For that, this CH2 group will be leaving. CH2 double bond CH2, that is an ethene molecule will be living at 200 degrees Celsius, and this system will get aromatized. That aromatization might be the driving force for this reaction. So first a 4 plus 2 cycloaddition reaction will be taking place between this diene and this dienophile. Then we will get a bridged system like this. Bridged cyclohexadiene system we will get, and then upon further heating to 200 degrees Celsius, a elimination of this ethene molecule will be taking place, leading to an aromatic system like this. Okay, any doubts? Now coming to our question number 4. Here also we have to predict the correct regiochemistry and stereochemistry of the product. So we have been given two starting materials as we can see here. So upon heating under thermal condition it will give a product A, and upon photochemical condition this product A is converted into another product B. So what is the reaction that is taking place here? So this is a diene and this is the dienophile. Okay, diene and dienophile. So this is a 4 pi system, this is a 2 pi system. It will undergo 4 plus 2 cycloaddition, that is Diels-Alder reaction first under thermal condition. So we can see this will undergo a Diels-Alder reaction and we will get this product. Means we will be writing it in the other direction. We will flip it and write. Then it will undergo a Diels-Alder reaction in this fashion. This bond will attack here. This will shift and one second. We have to flip this and write. So I will flip it and draw for you. We are having hydrogen, hydrogen and a double bond here. So this double bond will be attacking here. This will go and attack here and a cyclohexene will be resulting. So this part of the starting material will be coming as a bridge here, as you can see here. Okay, and as following the endo rule, this will be coming below the plane. Both the hydrogens will be coming above the plane according to endo rule of Diels-Alder reaction. Now we can see in this system these two double bonds are in close proximity. So under photochemical condition these two double bonds can undergo a 2 plus 2 cycloaddition reaction. Okay, a 2 plus 2 cycloaddition reaction will be taking place between these two double bonds, and hence we will get this cubane kind of system. It is not exactly cubane, but a cubane kind of system we will be getting. Clear? Can I assume you are understanding? You can respond in the chat box as well. Okay, okay. Now coming to question number 5. Here also we have to predict the regiochemistry and the stereochemistry of the product. We have to predict the correct regiochemistry and stereochemistry of the product. So what will be the reaction that is taking place here? Is it a 4 plus 2 cycloaddition or a 2 plus 2 cycloaddition? So we can clearly see here there is a diene and this is the dienophile. So under thermal condition, this diene and the dienophile will undergo a 4 plus 2 cycloaddition reaction. 4 plus 2 or a Diels-Alder reaction it will undergo, and we will get a product A. So we have to predict the correct regiochemistry and stereochemistry of this product A. So as we can see here, they have flipped this molecule such that this diene and the dienophile will be coming in the coming in close proximity, so that it will undergo a Diels-Alder reaction. So here they have just, I will show you how it is drawn. This is a lactone, pH O, double bond CO2 Me and methyl. So this will undergo a Diels-Alder reaction like this. And here a six membered ring will be forming. 1, 2, 3, 4, 5. See this one. 1, 2, 3, 4, 5, 6. This is the six membered ring that will be forming. That is shown here. Then the CO2 Me will be coming below the plane according to Endo rule of Diels-Alder reaction. That is what is shown here. And this group, this O, C double bond O, will be coming in the bridge position of this system. Is this clear? So we will follow Endo rule of Diels-Alder reaction. So that is important. Endo rule of Diels-Alder reaction is important. Then other thing is we have to rearrange the system in such a way that the diene and the dienophile will be able to react, and we will get the desired product. Okay. Now coming to the sixth question of the Diels-Alder reaction. Which of the adducts, some Diels-Alder adducts are given A to D, which is the main product of the following Diels-Alder reaction. So this is the diene that is given. So it is an EE type of diene. Type of diene, and this is a transalkene. The dienophile is trans and the diene is EE type of system. This alkene is E as well as this alkene is E. So what will be the main product of the Diels-Alder reaction? Hello? Can anybody respond? This is a simple question. The thing we have to keep in mind is whatever stereochemistry is there in the starting material, it will be maintained in the product as well. That the reason is because the Diels-Alder reaction that is taking place, it will be in superficial fashion. So there will not be any flipping that is taking place. Hence, the whatever stereochemistry is there in the starting material, it will be maintained in the product. Yeah, option B will be the right answer. So both of these alkenes, they are in EE fashion, so um, it will be coming in cis fashion. Since it is EE, both these methyls will be coming cis to each other. And this is in trans fashion, so CO2Me will be coming trans to each other. So the only answer in which the methyl groups are coming cis to each other and the CO2Me are coming trans to each other is option B. So the right answer will be option B. Okay. Now coming to the question number 7. It is one of the easiest question in this tutorial. So which of the following dienes cannot undergo Diels-Alder reaction? Which of the following dienes cannot undergo Diels-Alder reaction? So the important thing that we have to keep in mind for this question is the Diels-Alder reaction will take place only in cissoid conformation. If the diene is in transoid conformation and it is not able to attain a cissoid conformation, then it cannot undergo a Diels-Alder reaction. So as you have mentioned, the right option will be option D. So we can see here in option A, this can rotate, the single bond can rotate, and we will get a transoid conformation like this. And in this option B, this single bond can rotate and we will get an alkene like diene like this. And this is already in cissoid conformation. And this, since it is a cyclic system, the bond rotation is not feasible. Hence, this will be in permanently in transoid conformation and it cannot attain the cissoid conformation. Because of that, this diene will not be able to undergo Diels-Alder reaction. Is this clear? So the correct option will be option D. Now coming to the question number 8. So this question is taken from JAM 2018 and it is a 2-marker question. So the major product formed in the following reaction is. So this is a 4 plus 2 cycloaddition. As we can see, this is the diene and this is the dienophile component. So it will undergo a 4 plus 2 4 plus 2 reaction, that is Diels-Alder reaction under thermal condition. So what will be the product that we will be getting here? The right answer will be actually C, because this CO2CH3. So it is having a carbonyl group and that carbonyl group will be able to have secondary orbital interaction with the other lobes of this diene. As we have seen, it will follow endo rule of Diels-Alder reaction. Because of that, the CO2CH3, it will be coming below the plane so that it will be able to interact with these lobes. The lobes that will be coming on this side of the diene, it will be able to interact with the lobes of the CO2Me. Because of that, this will be the correct stereochemistry of the product. If secondary orbital interaction can be ignored, in that case, the ideally thermal product will be B. Okay, but here the endo rule will be taken into consideration, and because of that, option C will be the right answer. So we have to consider the secondary orbital interactions of CO2Me, that is endo rule. Because of that, the right option will be answer C. Now coming to question number 9. So here this is also a question from JAM. It is a multiple select question, or it is NAT type of question, numerical answer type of question. So among the following, the number of compounds which can participate as diene component in a Diels-Alder reaction is. So the number of components or number of compounds which can participate as diene component in the Diels-Alder reaction is. So here also we should consider about the cissoid conformation. Cissoid conformation of diene. So here, if we see the cyclopentadiene, it is in cissoid conformation. This cyclohexadiene, it is in cissoid conformation. This anthracene, this this part will be taking place in the Diels-Alder reaction. So it is also in cissoid conformation. This furan, if we consider, it is also in cissoid conformation. The cyclobutadiene, it is also in cissoid conformation. This is a cyclic system, as we have seen in the other question. uh, it is in trans conformation and it cannot rotate the single bond so that it will be attaining the cissoid conformation. So this will not undergo Diels-Alder reaction. And if we consider this system as well, this rotation of the single bond is not possible. Hence, this system will not undergo Diels-Alder reaction. It cannot attain a cissoid conformation. Because of that, it will not undergo Diels-Alder reaction. And here we can see both the dienes are in cissoid conformation. It will undergo Diels-Alder reaction. So the right answer for this question is 6. Out of this given compounds, 6 compounds can act as a diene for taking part in Diels-Alder reaction. Is it clear? Hello? Clear, right? Now we will move to question number 10. So the reactivity of the compounds with malic anhydride follows the order. So what will be the reactivity order? So the diene should be more electron rich so that the reaction rate will be faster. So malic anhydride, which is given here, this is the dienophile. So the condition for Diels-Alder reaction to take place is the dienophile should be electron deficient and the diene should be electron rich. As the electron richness of the diene will be increasing, the dienophile can react faster and hence the reaction will be faster. Diels-Alder reaction will be faster. So out of these four, which one will be more reactive diene? So this is a permanently cissoid conformation. So this will be the most reactive. Then this one, the rotation about this CC bond will be not feasible, as this is a bulkier group. Tertiary butyl group is bulkier, and if we draw this conformation after rotating, these TBU groups, it will cause sterical hindrance. So because of that, this will not be that much reactive diene. Then out of these two, both of these can rotate and give the diene. So this because of the presence of this CH3, according to electronic effects, this CH3 will be releasing electron, and hence this will be electron rich system. So the order will be 1, then comes 3, then comes 4, and then comes 2. 2 will be the least reactive because of the steric hindrance that will be caused by the tertiary butyl groups. This is in permanent cissoid conformation. So cyclopentadiene is a good diene that can undergo Diels-Alder reaction at a faster rate with the malic anhydride. And out of these 3 and 4, because of the presence of this CH3, which is an electron releasing group, so this will have a more electron rich nature compared to simple butadiene. So the right answer will be option B. Is this clear? Any doubts? Hello? Now moving to question number 11. So which of the addex A to D is the main kinetic product of the Diels-Alder reaction? Any answers? So this is the diene component and this is the dienophile. So we are having an electron releasing group on the diene and an electron withdrawing group on the dienophile. So if we consider the diene, this will be the most electron rich center of the diene. And if we consider the dienophile, because of the electron withdrawing nature of the electron withdrawing group, that is CO2Me, this will be the most electron rich, deficient center of the dienophile. So the most electron rich center of the diene and the most electron deficient center of the dienophile, it will be aligned and the Diels-Alder reaction will be taking place in that fashion. So we can see this is the electron rich part of the diene and the electron deficient part of the dienophile. So it will attack on the diene will be attacking on the electron deficient side of the dienophile and it will go and attack here. So we will get an ortho product. So we can rule out these two options, option C and D. And out of these two, A and C, the right option will be C because the CO2Me will be following endo rule and it will be coming below the plane. Okay, CO2Me will be following endo rule and it will be coming below the plane. Because of that, the right option will be option C. Here also we have to take into consideration electron rich center of diene and electron poor center of dienophile will react first. So because of that, orthoselectivity is coming. And the second thing we have to follow is endo rule. So the right option will be option C. Clear? Now coming to the last question. The structures of the major products X and Y in the following transformation are. So here a cyclopentadiene and a dienophile is given. Under thermal condition, it will undergo 4 plus 2 cycloaddition and it will give X. And under photochemical condition, this X will transform into Y. So what is X and what is Y? That is the question. Any answers? So we can see this will follow Diels-Alder reaction endo rule. So if we are drawing like this should come inside. I will draw this little more neatly. This is our diene. This is the dienophile. And we will get this will go as a bridge, and here a double bond will be there, and this will be coming downside. So this is our product X. Now this double bond and this double bond, it will undergo 2 plus 2 cycloaddition. So those sort of reactions involving carbonyl group that we are known as paterno-Bucchi reaction. Paterno Bucchi reaction. So it will undergo a 2 plus 2 cycloaddition and we will get this oxetane kind of system here. So the right option will be option number 3. Clear? Right option will be option number 3. Any doubts? So we have discussed all the questions based on Diels-Alder reaction and 2 plus 2 cycloaddition reaction that was covered in this week 2 modules. So if you are having any doubts regarding any of the questions that we have discussed here or any of the part from the module, you can ask now. Okay. If there are no doubts, we can wind up today's session and we can meet next week. Thank you.